Welcome back, CSE 121, Fall 2020, to Part 2 of our Polygons Everywhere exercise. It's number 13 for Fall 2020, exercise 13. And for polygons everywhere, so far we have polygons, and they're random polygons, but they're not everywhere. So we need to make them everywhere. And we have random color, random number of sides, random length, and next we're going to do random position. We're going to need go-tos for that. So we're going to throw in a go-to, and that's going to be before he starts to draw his fill. So every time we go to, remember we do like a pen up, and then he goes go to and we do pen down. We're going to do that. So before the begin fill, we're going to do a pen up because we don't want to see a pen every time they go somewhere. So we're just going to do that. We already know that ahead of time, and maybe you don't, but we're going to do t.pen up, and that does not get an argument. And then we're going to do a t.goto, and I'll just put 0, 0 for now, just as a placeholder, because that's where they are actually. And then I'll do t.pen down, so that when the pen's down, then we can start drawing these shapes, and you'll see the outlines of them. So that's why we're doing pen up when they go somewhere, and then they go there, and then pen down when you start drawing the shape. So that's all we'll add. But what we're going to do is put random numbers in here. So what I'm going to do is, instead of 0, 0, I'm going to call one ran x, and then for the y, what do you think I'm going to call that? You got it, ran y. And if you want to put underscores in there, that's fine. I'm just leaving out underscores right now. So ran x and ran y. Now we have to define ran x and ran y before we get there. But we can do it in the function because we want it to happen new every time. All of these are being defined inside the function, so they're brand new every time the function runs. So the last thing we'll do here is we'll say ran x, and we have to do two of these. You can't do them both together. So we'll have to do ran x equals, and then after this we'll do ran y equals. Now I didn't fill them in yet, but they're going to be numbers. So I'll do random.randint, and randint's coming up now, and I'll just leave that blank, and I'll do the same thing here. I could have done 1 and then copied it, and there's my randint. And what I'll do next here is define a random number. So what is it going to be? Well, this is 0, 0, and this is, I think they go out to like minus 200 this way, minus 200 that way, maybe even a little further. We could probably go a little further based on where they're starting. So, or you could do 250, anything like that. So let's just try it. So let's just say we're going to go minus 250, comma, 250. That means for the random x, he could go anywhere from minus 250 to plus 250. And same thing with the y. We could go from plus 250 to minus 250. So we're just going to do that. They'll be the same. Now, we might do the same thing here. Matter of fact, we probably will. That will do maybe 25 times 10 or something. So they don't, go in every single increment. That's a lot of random increments in between. And sometimes if we do them in blocks of 10, it just looks a little better. So if you understand that from what we did here, we could do it here too. So instead of saying 250, I'll just do 25. And because we're multiplying, we shouldn't have an issue because we don't want to be putting decimals or anything in here. But I'm going to put times 10. And that way everything will go on increments of 10 when we do it. They won't go in increments of 1 because you wouldn't know the difference between minus 250 and minus 247 or anything like that. So we'd rather have them go in bigger jumps. That's what these things are doing. Once again, if you're confused at all why I'm making these numbers smaller and doing multiplied by 10, it's because I just want them bigger jumps. Bigger jumps. Then you know why we did this. Bigger jumps with the times 10. So they're using basically intervals of 10s when we do that instead of intervals of 1s. That's why it's doing that. So now, when we do this, let's see what happens. We have our ran x, we have our ran y, and we are using this and see if that works. And let's just see. There's one over there. There's one over there. There's one over there. So it's working. So they're going in random locations. Except we're running it each time and it's starting over. Now some may be even off the screen slightly. But everything looks okay. So that's working. So we're almost done here. Now that we have that, now that that's working, we have all our randoms. We have random color. We have random number of sides. We have random length of sides. And the last thing is our random location, which is ran x and ran y, of where they start to draw. And that's why we're using that right here. Now, if we want this to happen multiple times, let's say you want this to happen 10 times. Now, you could just go here and copy this and paste this 10 times and just have 10 calls. But we already know how to multiply things. We do it right here. We have a for loop here. What if we just did this? What if we just did for I in range and put like 20. We'll do it 20 times. And I'll put my colon. What if we just ran this function 20 times? Let's see what happens. Here we go. There it goes. And see, they stay there. So it's all part of one. So now we're seeing them all over the place. And it's like magical because it's like fireworks going off. You could even make them faster if you want. You could add different colors, whatever you want. But now there's a little more variation. Now, if you don't like any of the colors, I think I have a dark green in there. I could go here and just make it green. I could add another color, like, maybe there's probably a gold somewhere, or I think orange actually is. I don't have orange in there, so I'll throw orange, and I just have to remember that I have it in quotes. Orange kind of looks like gold, I think, and I made it a regular green. So if you wanted lighter colors, you could do that, and you could change anything you want about it. If you wanted 30 of these, you can do that. So, and if you wanted to change the speed, I'll just make it 0. I think 0 is the fastest, so I put in 0 there. Let's try it again. Oh, look at that! Look at that! How exciting is that? It makes you just want to send a video card to somebody, which is polygons all over the place. And, if you want to do more of them, go here and make 30 of them. So you could go here and make 30 of them. Look how awesome that looks. You could just watch these all day and just have fun with it. So it's a little more fun, if any small children, you play this for them and they could just hit that run button all day. They'll be occupied completely. So anyway, I think that's it. I think that's all we have to do for this one. It's just this one big function where we're generating all these random numbers in here. And the only thing a little tricky is we took some of these numbers and just kind of cut them down and did a multiple of 10 afterwards. We multiplied by 10 afterwards just so they'd go in bigger chunks. And then all the values we're using are basically random. So we're really using this random module for a lot here. We're choosing a color with the random choice method, and then we're using random integers to figure out the length, to figure out the sides, and also a random int is figuring out the locations between this side and that side, and between the y's up and down. So, and then we're just drawing polygons. So obviously there's a lot of different things you could do with this. And one thing we are making sure to do is run a loop so that it runs how many sides you have. It's 360 divided by the number of sides. So we already figured that out up here, and it's using the random numbers in here, but the angle is always going to match up to it. And then we're hiding the turtle at the end, and we're running the function call is basically going in a for loop. So that's it. So that's all you have to do for this one. So when you're done, just share it. And make sure you go down to copy link and go to your My Warren. You're probably logged out of it by now. And I'm going to go in coursework for CSE 121. And under Unit 11, there it is, Polygons Everywhere with an exclamation point. And if you go in here and you add a comment and you insert a link, just paste your link that you just copied in there. And then choose New Window so that it opens in a new window. And that's it. And that's it with polygons everywhere. And we're going to do some more things with polygons. We might put them in rows and things like that just to understand arguments and parameters a little bit more. But that's a nice fun one to kind of loosen up a little here. Anyway, that's exercise 13, polygons everywhere.